Welcome to This Explainer. Today, we're diving into a scientific projection of our world that's, well, it's pretty terrifying, but absolutely crucial to understand. We're looking at what actually happens after a nuclear war. You know, when we think about this topic, our minds naturally go straight to the explosions, right? That immediate, unimaginable destruction. But the scientific data reveals a much darker truth. Those initial explosions, they're really just the beginning. The aftermath, which is driven by a cascading collapse of our global climate and agricultural systems, is actually far deadlier than the blasts themselves. Just look at this stark quote from the research. Nuclear war would forever split human history into anything that happened before and the post-war apocalypse. It really sets the stakes here. This isn't just about changing borders or shifting political power. We're talking about a fundamental, irreversible rupture in the human timeline. Everything we've built, everything we know sits on one side of that divide, and on the other side, a radically different, hostile world. Okay, so let's really dive into this. To understand that post-war apocalypse, we have to answer this core question. What exactly happens after the blast? How do we get from a localized, intense release of energy to a global civilization-ending crisis? Well, it all comes down to a horrifying chain reaction, and it starts the very millisecond a weapon detonates. Part 1. The catalyst. The global firestorm. A detonation forces a gas bubble into existence that is, quite literally, hotter than the core of the sun. This bubble expands incredibly fast, creating a massive shockwave that breaks everything in its path. But it's the heat that triggers the true catastrophe here. Everything within kilometers instantly begins to burn. If this happens over a populated area, the shockwave shatters structures, and the immense heat ignites them, sparking mass fires across tens of thousands of square kilometers almost in an instant. And as these individual mass fires merge, they build into something even more dangerous, a global firestorm. The heat burning through cities and forests warms the air so intensely that it actually creates its own wind system. It's basically a microclimate. This hot air rises rapidly, pulling in fresh oxygen from the surrounding areas, which just stokes the flames even further. This violent updraft forms a colossal pyrocumulonimbus cloud. It functions like a giant chimney, forcefully pumping soot and smoke high into the sky. Which brings us to part 2, the consequence, how nuclear winter begins. Now, what's really interesting here is the vital difference in altitude. Under normal conditions, like a regular forest fire, soot stays relatively low in the atmosphere and is quickly washed out by rain. But the sheer power of a nuclear firestorm pushes that soot all the way up into the stratosphere. Up there are no rain clouds. There's no weather at all. There is absolutely no natural mechanism to quickly wash that soot away, meaning it stays suspended aloft for years. In a full-scale exchange, warring nations following the logic of mutually assured destruction could detonate thousands of weapons. That creates hundreds of these firestorms, pumping an estimated 150 million tons of soot into the stratosphere. Just picture a solid block of pure black soot, the size of a massive skyscraper, injected directly into the upper atmosphere. Over the next few weeks, that soot spreads out, blanketing the globe. It absorbs sunlight high above the Earth, preventing it from reaching the surface. Yesterday, the world was normal. Today, a decade-long climate disaster begins. And that triggers part 3, the collapse, the death of agriculture. It all boils down to this simple reality. Our food eats the sun. Now, while nuclear winter isn't a permanent new ice age, it is an immediate climate change event that happens over a matter of weeks. That's way faster than any plant or animal can adapt. Less sunlight hitting the Earth means the climate system is completely disrupted. Evaporation over the oceans drops, causing severe, large-scale droughts. Our carefully predictable seasons become erratic. Summers become dramatically shorter, much colder, or in severe scenarios, they literally disappear altogether. And this directly threatens the mid-latitudes. That's the temperate strip of land wrapping around the globe where the vast majority of human food is grown. We're talking about the highly efficient breadbaskets of the world, like the US Great Plains and Ukraine. In a severe nuclear winter, temperatures in these crucial agricultural zones would likely stay below freezing for several consecutive years. Farming as we know it would become mathematically and biologically impossible, which turns human survival into a cold, unavoidable math problem. Calories produced versus calories needed. Humanity as a whole only ever has a few weeks of food supply in reserve at any given time. If global calorie production suddenly crashes below the minimum threshold needed to feed the population, the equation balances itself in the most tragic way possible. If you have more people than calories, very quickly, you don't anymore. But wait, the climate isn't even the only hurdle. Even if some areas had enough sunlight to grow crops, modern agriculture is incredibly fragile. It relies on a continuous supply of industrially produced fertilizer, chemical pesticides, and massive amounts of fuel for specialized machinery. If the nations that produce and refine these agricultural inputs are targeted in a nuclear exchange, the entire global supply chain vanishes overnight. You just cannot run a modern high-yield farm without oil refineries, functioning ports, and specialized machine parts. Let's look at part 4, the reality, real-world conflict scenarios. Impartially walking through the data experts use here, look at the first row. Even what is modeled as a mild regional exchange between India and Pakistan with low-yield weapons results in 27 million immediate deaths. That's more than all of World War I in just hours. The resulting soot causes nuclear autumn, starving up to 250 million people globally. If that same regional conflict escalates, immediate deaths quadruple and global calories are halved. Finally, row 3 outlines a full-scale exchange involving NATO and Russia or China. The immediate deaths hit 360 million, and global agricultural output plummets by a staggering 90%. To put that full-scale scenario into perspective, scientists literally describe it as humanity dropping an asteroid on itself. With an estimated 4,400 weapons detonating, we have no historical event to compare this level of absolute, instantaneous devastation to. It's an entirely self-inflicted extinction-level event that would immediately erase the infrastructure of the modern world. Let this number sink in for a second. 2 billion. This is the projected number of people who would starve to death globally from an escalated regional war between India and Pakistan. This means a localized conflict halfway across the world would disrupt the climate enough to slowly starve 1 in 4 humans alive today. And here's the projection for a full-scale conflict: 5 billion. Within 2 years of a NATO versus Russia or China exchange, starvation would claim 5 billion lives. In the targeted mid-latitude regions, so that encompasses Russia, China, Canada, the US, and much of Europe, the climate shock and loss of infrastructure would be so profound that only a few % of the population might even survive. Which leaves us with part 5, the aftermath. Can humanity survive? Well, science suggests that while nowhere is truly safe, survival is mathematically more probable in the southern hemisphere. All the current nuclear weapon states are situated in the northern hemisphere. Consequently, countries like Australia, New Zealand, and Argentina might actually endure. The atmospheric effects of nuclear winter would be milder down there. Furthermore, these nations have a heavy reliance on livestock, which are somewhat more resilient to sudden climate shifts than fragile crop systems. But, their survival relies heavily on them completely halting food exports to protect their local populations. And that's assuming they aren't invaded by starving nations desperate for resources. Ultimately, human civilization as a global, interconnected entity would collapse. The survivors would be thrown back thousands of years in development. And it leaves us with this final, haunting question to consider. When those survivors finally rebuild civilization, would they ever build nuclear weapons again? It's a stark reminder of the absolute existential necessity of ensuring these weapons are never used. I highly encourage you to look deeper into the resources and expert organizations we've based this explainer on to understand more about this critical topic. Thank you so much for joining me today, and keep learning.